Now in this case, if I am considering my VGS for 8 volts, you can say saturation occurs at 6 volts. The saturation level for VDS is related to the level of applied VGS by VDS sat is equal to VGS minus VT. You can say for a fixed value of VT, when this value is fixed, the higher level of VGS, the greater is the saturation level. That means this value is constant. So VDS sat and VGS are directly proportional. So if this value is larger, your VDS saturation will be larger, or you can say the greater value. So for the characteristics, you can say VT is assumed to be 2 volts since ID equals to 0 milliampere for your gate to source voltage less than VT. That is, the current basically flows in the MOSFET when your voltage, gate to source voltage, is greater than the threshold voltage. That is, it causes the significant increase in the value of the current. Can say as VGS is increased from VT to 8 volts, we are increasing value of VGS from VT to 8 volts, the saturation level, the value of ID increases from 0 to 10 milliamperes. Can say the value of ID increases from 0 to 10 milliamperes for increase in value to VGS from 0 to 8 volts. These are the various values of VGS. As you increase the value of VGS from VT to 8 volts, you can say 2 volts to 8 volts, your value of current increases from 0 to 10 milliamperes. This is the significance. Then what you can say, for VGS greater, the drain current and VGS relationship is given by ID equals to K into VGS minus VTN the whole square. The relation between the current and the gate to source voltage and the threshold voltage for N channel. VTN is the threshold voltage for N channel MOSFET. For P channel you have plus VTP, that is just the difference between the formula for N channel and P channel. Can say the above equation contains square term. This equation 1, contains the square term in it, which gives non-linear relationship. We can say linear relationship is when your y is increasing with respect to x. This relationship is called as linear relationship, but because of this square term, the relationship is non-linear, and k is a function of the construction of the device, or we can say k is related as ID on the value at which your current is flowing upon VGS on minus VT the whole square. That is, rearranging the equation 1 will give you this value. Now can say k is equal to ID on, I am writing the equation again, VGS on minus VT n, if it is n channel, the whole square. Now if my ID on equals to 10 milliampere as from the transfer characteristics, and VGS on equals to 8 volts and VT equals to 2 volts, then I can find the value of k. After substituting, I will get it as 0.278 milliampere per volt square. Why volt square? In the denominator you have this square term, so it becomes volt square. In the numerator you have current, which is in milliampere, so it is ampere per volt square. Milli, of course, it will come after simplification. So we got k the value as like this. So for this particular value, I can find ID as 0.278 into 10 raised to minus 3 VGS minus 2 volts the whole square. So you can say this is the equation for drawing the characteristics. So you can substitute the various values of VGS, you can find the value of ID, right? So for example, if we say VGS is 4 volts, I can find ID as 0.278 into 10 raised to minus 3 4 minus 2 the whole square. This will give me the value of ID as 1.1 milliampere. So you can say for VGS 4 volts, I am getting ID as 1.1 milliampere. So for this, you can see for VGS is equal to 4 volts. If you are drawing, this is the characteristics, so it will give me 1.1 milliampere current. So this is how we can draw the characteristics for MOSFET. Thank you for watching in 5 minutes.